Okay, we will see how to draw a 3D frame and how to analysis a 3D frame using MMS programs. This program is meant for educational purpose, where a small frame can be drawn by the students and they can visualize their bending moment and shear force in both the axis, that is vertical and lateral. Okay, so first we will draw the frame. So click analysis, go to 3D analysis. Okay. This command shows that how we can draw a frame on this drawing paper. Okay, so the steps are explained over here, which has to be followed, which I will explain you by step as I draw the frame. Okay, so let us click this drawing paper. Okay, so here a flow has been shown that how you have to use uh, drawing paper. If you are drawing a 3D frame, then first draw the typical floor plan. Okay, and second, after drawing the when the after you draw the plan completely, you have to click rotate command, and then you have to insert the columns to the floor slab. Okay, and then use repeat story command if you want to repeat the story, and then you have to fill the text box. We will see how that is to be done, right? So this is a page. Okay, so this point is 0 0. Okay, sorry, first of all we have to select the scale, because if you don't select the scale, then the computer will take it by default and then you will not be able to change it. Okay, so before start drawing anything, first select the scale. Say 1 unit is equal to 1 meter. This is 1 unit. We are taking this as 1 meter, right? So let us select this. Okay, so this is the starting point, right? And that is 0 0 over here. Okay. Now we are going to draw a floor plan which has two slabs, square slabs, that 5 meter by 5 meter. Okay. So let us start drawing from here. Okay. And set the cursor properly on the grid. Okay. So okay, it okay. So this is this click over here. That is the start point of the member number one. Okay, and the width and the length of the member is 5 meters. So 1 2 3 4 and 5. Okay, 1 2 3 4 and 5. So click over here, right? Okay. Uh, so this is the second point. Okay, now write the length of the member. The length of the member is 5. Either enter, either press enter to save this data or click OK button, right? We will press enter. Okay. Now let us draw the second member. Click over here. 1 2 3 4 and 5. So this is the second point. Again, length is 5 meter. Press enter. Now let us draw the third member. Here, 1 2 3 4 and 5. Okay. So this is the last. This is the end point of the member. Member number three, and the length is say 5 meters. Okay, write 5, press enter. Now let us draw the fourth member. Click over here. 1 2 3 4 and 5. This member number 4, length is 5 meters. Press enter. Again, click here. 1 2 3 4 and 5. This is going to be the fifth member, right? Click here. Member number 5. Okay. Again, length is 5 meters. Press enter. Click here and click here. Right? Okay, this is member number 6. Length is again 5 meters. Press enter. Okay. Now let us draw the last member, right? Click here and click here. Okay. Again, the length is 5 meters. Press enter. Now rotate. Click command rotate, which will rotate the floor. Okay. Okay. Now this is the command through which we can draw columns. We can assign the columns at the required point. Click this command. Write the height of the length of the member. Select length of the column is 4 meters. Press enter. Okay. Now we have to select the point where the column is to be drawn. Okay. So let us select the point. Select the first point where it is to be drawn. Say over here. Then click anywhere on the paper. Okay. So the member is drawn. Click here. Click anywhere. Click here. Click anywhere. Okay. Click here. Click anywhere. Right. Click here. Click anywhere. Okay. Click here. Click anywhere. So we have drawn columns of length 4 meters. Right. Okay. Now this is the command to close the insert insert column on command. Right? Now this is the command where you can insert a beam which falls from joint to joint. Say I want to draw a beam from this joint to this joint. Okay, so you can use this command. Okay, does both end of the new beam that is to be inserted fall on the existing joint? Yes. This is the existing joint. This is the existing joint. So yes. Okay. Click here. Click here. Okay. So your member is drawn over there. Write the length of the member. Say it is 5.5 meters. Press enter. Okay. Are there any further beams to be inserted? No. Okay. So uh, this is how the beam is being inserted. Now this is the command where you can draw a beam parallel to any beam, existing beam, right? Offset. Okay. Write the number whose another parallel member is to be drawn. Say I want to draw a member parallel to member number 7. Then write 7. Enter. Write the distance in meter negative if downward is positive. So I want to insert a member over here. So this distance is going upwards, so it will be positive. If I had to draw this member parallel to M3, then the distance would be downwards, then I had to give a negative sign over here, okay? But as the distance is upward, I will have to give a positive sign over here. Say my member falls at a distance 2.5 meters from M7. So 2.5, press enter. Okay, so the member is gone, right? Okay. So this is how this command can be used. Now this is a very important command. Okay, you can repeat the story, and this is a very good, very important command where you want to repeat the way. Now we want to repeat the story. Click this command. Write the number of stories to be repeated. Say one. Okay. Write the typical height of the story. You can change the height. Over here we have taken 4. This can be 3, 4, anything for requirement. But we will take 4. Press enter. So the story has been drawn, right? Okay. Now this is the command which turns off the label. This is the command which turns on the label. This is the command which turns off the text box. This is the command which turns on the text box. Right? Now this is the command which identifies the column and make the column turn blue. Okay, so you can see you can differentiate the columns and beams, and this will turn it back. Okay, so you by this you can move the frame up, down, left. Say I want to move the frame down. Okay, so I will move the frame down. Now, uh, this is a command where you want to repeat some of the members for one story. And this, Say I want to repeat this few members. Sorry, select on. Okay, I want to repeat a few members. Okay, which I am selecting it. Okay, okay. So the selected members have turned to be green. Now write the number of stories to be repeated. Say one. Okay, and the height. Again, you can change the height. Okay, but we will take 4 meters. Press enter. Okay, so the those members are repeated for further one story. We can see that we have missed this column. Okay, so we can again select on, select this member. Okay, right now write the number of story to be repeated one, and the height is 4. So okay, that member has been drawn now. This is how you have to draw the frame, right? Once the frame is drawn, then you have to fill the properties. Okay? Over here, uh, we have to give the width of members and the depth of members. Right? Say the width of member is 0.25 meters and the depth of members is 0.45 meters. Right? Now, when you bring the crusher, you can see the member number in green, right? You can click that member. When it turns to blue, it means it is selected, right? Click, you when it is when it turns blue, it means it is selected, right? Now you can see the member properties, right? Click this. When you bring this over here, you can see the B and D for that member, B and D for this member. We have not given any data for this, so it is showing 0, 0, right? So this is how you can check the member data given. Now say all the members are of the same section, select all. You can select all the members together, right? Okay. So all the members are turned to be blue. Okay. Uh, Let us take this as point two. Sorry, point 25, and this is point 45. Let us select all. Okay. Again. Okay. Click member property. You can see all the members are being assigned with the member property. And the width, right? Now, if you want to change data for any member, click on that member, it will turn to red. Give the value required over there. Say I want to change this to 0.45. Okay. Then again, re-click the member. As it turns to blue, that means the member properties have been changed. You can click. Okay. So this is 0.25 and 0.45. This is 0.25, 0.45, and this has to be 0.45 and 0.45. So you can see the RCC frame, then you can see front, right, rear, left. So okay, again, so the member property will be assigned. Okay. Are you sure? No further data is to be given. Yes. Okay. Now, next step is we have to fill the text box, right? So click finish. Okay. Have you filled the joint numbers in the text box? Okay. We have still not filled the joint number. So, okay. Click command field text box. Okay. Field text box and number the text box. Now, when we click this command, uh, the text box will be filled by itself. Okay. Numbered by itself. After clicking that, you have to again re-click finish and then save the file. Okay. Okay. So you can see this white box text box, they represent the frame joints, and yellow text box, they represent the support joints, right? So the last frame joint is 20. Okay, so click finish. Have you filled the text box? Yes. Write the total number of joints. So write 20, press enter. Okay. Are there any further lines to be drawn? Do you still want to draw any members? Uh, we will write no. Okay. Are you sure no further lines are to be drawn? Yes. Okay. So let us save this file name. Okay. Now this is a message populated because there are some. This is the inclined member, right? Which is not exactly in in x-axis or y-axis. It is in xy plane. So by clicking just over here, the value of z coordinate for this member will be taken as 0, right? So just click yes. Okay, just click yes. Right. So this is how the input has been uh, created. Okay, let us save this in. Are you sure no further editing is to be done? Yes. Okay. So let us save the same uh, in the same file which we named M. Okay. Press enter. Okay. So the data has been saved. Now this page shows the positive x-axis, y-axis, and z-axis. So these are the positive load direction and the bending moment and shear force which we get through this load will be denoted as BM1 and SF1, and these are lateral loads, okay? And the bending moment and shear force which we get from this load will be denoted as BM2 and SF2. Okay. Now over here we have to do the loading to the frame. So open drawing. Okay, so this is a drawing which you have drawn. Now over here you can select the type of loading. Say vertical UDL acting vertically downwards. The magnitude is 50 kilonewton per meter. Okay, press enter or click OK. Okay. Now you can assign, just bring the cursor to the member. When the member turns green, that the member is selected. When you click it, okay, it will turn blue. That is the loading has been assigned. Okay. So say we are going to give UDL to some of the members. Okay. And say over here. Okay. Okay. Right. Now assign the value. Okay. Now you can see the loads. Okay. We have given UDL. Okay. So you can see the UDL has been given over here. Now say you want to give some UDL acting in lateral direction. Again, the magnitude is 50 kilonewton per meter, right? Then press enter. Okay. So these are the members. Okay. Click, click. Okay. And you can see the load. Okay. Right. The lateral loads are uh, uh, now acting on the selected members. Please remember, as we are given positive sign, so this is the positive direction, okay, the loading. If we will give negative, then it will be in the opposite side. So let us assign the value. Okay, the values are assigned, right? So now we have completed giving the load to the frame. So let us exit. Okay. Let us click finish. Are you sure no further editing is to be done? Yes. Let us resave. Let us save this data in the same file name M. Okay. Press enter. Okay. Now click here. Uh, uh, we will click the design form and go to program list to run the 3D frame analysis and see the output. Okay. So over here, the whole input, that member data and the loading has been given and the file has been created. Now we will run this file and do the analysis. Click design, program list, okay, run analysis. Now say we will be assuming some value of modulus of elasticity is set to E to E E E8. Okay. Now press enter. Okay. We have to follow this instruction. Always use enter key after filling the data in the text box. Then only it will be saved, right? So press enter. Say, write the value of rigidity. Okay. If you don't remember the say it is 2E7. Press enter. Okay, I've taken this value randomly. Now we have to give the we have already given load. So over here we will write load factors as 1. Sorry, and 1. Right? Now click finish. Please after entering the values, enter always, right? Click finish. Okay, now you can see the output. This is the output of the frame. These are the displacement and joints, displacement in each joint. Okay, for member number one, this is the axial force, this is twisting moment, this is bending moment one, this is shear force one, bending moment two, shear force two, right? Now we can view the okay. So this is the drawing. Now let us first turn off the labels, right? And let us move the frame to right. Okay, now we can zoom the frame, right? Let us zoom the frame. Right? Now when you bring the cursor at any member, it will turn green and that member is shown over here, right? So this member is M41. We want to see the bending moment and shear force of M41. So right, okay, enter the member number whose joint number or whose joint numbers are to be viewed. So we'll write 41 over here and press enter. Okay. So you can see the joint numbers are viewed over here, right? Join 19, join 20. Okay, now by clicking this, you will be able to see the bending moment in vertical direction of the whole frame, right? You by clicking this, you will able to see the shear force diagram of the whole frame in axis 1 1. Similarly, in axis 2 2. Okay, right? You can also see the bending moment and shear force of the individual frame, right? This is the bending moment one, this is shear force, this is bending moment two. You can zoom positive, sorry, negative, I've done negative. You can zoom positive. Okay, you can do zoom positive. This is the shear force, you can do zoom positive as the moment is very small. Okay, and over here you can get the values of shear force and bending moment 1 and 2 for this beam 41, right? Sorry, 41, beam 41, that is this beam, right? Uh, so at the distance 0, that is IP, that is over here, right? This is IP, this is TP, okay? So IP, point IP, the distance is 0, okay? And in between, if you want to see, say I want to see the shear force and bending moment at a distance 2 meters from IP, write 2 and press enter, okay? So you can see the shear force and bending moment at the distance 2 from the initial point. Uh, so this is how uh, the 3D frame can be drawn and analyzed by MMS program. Okay, and this is how the students can learn and check their results with this software. Thank you.